Hello everyone. Today in this video, I'm going to talk about a special use case scenario wherein machine learning algorithm ML plays a crucial role. This is where ML comes very handy. For example, I'll give you some kind of situations. For example, you have a problem, okay, which is very complex, very complex. Okay, so this is a complex problem, and if you want to solve this through if you want to solve this through conventional programming methods, if you want to solve this through conventional programming methods, it is very complex. Or consider you have a problem wherein you can't really write any algorithm. I mean, for you have a problem for which there is no algorithm there is no algorithm possible for this particular problem. So for these kind of scenarios, for these kind of situations, machine learning comes very handy. I'll give you an example, real-time example, wherein these two scenarios comes into picture. Okay. So the first scenario is so the first scenario is speech recognition. So what is the speech recognition? So whenever a sound is played, whenever you hear any noise, you need to recognize that. Okay. For example, you usually turn on your Google Assistant and you just say, "Okay, Google." By recognizing your voice, it usually responds to your speech. That's nothing but voice search or speech recognition, whatever you call. Okay. Here, the main purpose in this particular scenario, which I am going to explain right now, here the problem is you need to distinguish between the two sounds. Okay. For example, you have two sounds, that is spelling out this particular word, that is one, and the another situation is spelling out this particular word, that is two. Whenever I say one, I'm starting with low pitch. See here one, one. So one is nothing but we are actually starting with low pitch. Okay. But whenever I say two, here we are not at all starting with low pitch. Why? Because see the sounding here. I'm not saying who. I'm saying two. I'm saying two. Two in the sense it is hitting very hard. So it is the high pitch here. Okay. And whenever I say four, 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 it's also somewhat low pitch. Four. And whenever I say six, it's again high pitch. Six, high. Seven, high. Or 8, it's again low. 8 is again low. 8. See, the first two letters are 8. In the sense it is low. And again, when I say 10, 10 is actually here, TE is actually hitting very hard. So it's again high pitch. So why am I saying all these things is I want to make a difference between the sounding of each of the words. For example, my algorithm needs to recognize whether it's a low pitch sound or it's a high pitch sound. My algorithm needs to recognize that. Okay. So here, but this method won't be applicable. Uh, but this method won't be applicable for thousands of words spoken by millions of people. For example, when you just look at the globe here, we have millions of people around. Okay. For example, Google is used by millions of people every day. So millions of people usually go to this okay Google, and they'll do some search through their voice. But when you write the conventional programming, of course you can identify low pitch, and of course you can also identify high pitch, but that would be very limited scenario. Why? Because it's only limited for pause for particular situation. But when it comes to millions of people speak millions of words, okay, and each of the word is having different kind of sounds, okay, and each of the people is having different kind of accents. Their accent is different, so their sound would be different, so their uh, pronunciation would be different. And along with this environment, we also have some other noises, like maybe you may hear car sound or any other vehicle sound nearby you. So by managing all of these external sounds, that is car sound or any pollution sounds, noise pollution, anything, and you also need to manage this accent. This accent need to be managed, because many different people have different accents. And also millions of people around the globe usually speak millions of words. So considering all these factors, you need to write some of the rules. You need to write some of the rules which usually does the job for recognizing the speech. Okay, for recognizing the speech, you need to write some kind of rules. But just imagine, this won't be possible in the conventional programming. Why? Because we can write these rules for one or two situations, but for each and every millions of words, for each and every accent, for each and every car sound, everything, every particular sound, we can't really write rules every time. So here, then what is the solution? Then how to solve this problem of recognizing the speech, that is voice recognition? Simple. You just go with machine learning. I suggest you. So write an algorithm based on the machine learning. So I'm suggesting write an algorithm based on ML. Okay. Then what it does is it usually learns by itself. Learns by itself. There is no need of human intervention here. Okay. But you only need to provide the recordings. You only need to provide the recordings for each and every word. Nowadays, data is easily available. Earlier, data is very much limited. The scope of collecting the data is very much limited. But nowadays, data can be gathered very easily. We have so many machine learning repositories, and we have so many data sets so available across the globe. So you can use whatever data you want. So by feeding the data, by feeding this data to the machine, to a machine learning algorithm, we can easily find out the patterns that are involved in the data. Hence, we can easily recognize the voice. So this is the kind of situation I really want to share this to you, this with you all. So that's the scenario. So I'll see you in the next video. I hope you like the content. If you just like it, just share it with your friends. Take care. Jai Hind.